The night skies have been a main attraction lately. Welcome back to Techstination. I'm Fred Fishkin. Joining us from Unistellar is co-founder and astronomer Franck Marchis. Hi, Franck.
Hi Fred, how are you?
Great to see you again. The last time we spoke, we were chatting about your new Envision smart binoculars. I think that's still on Kickstarter. And
Yeah.
you also have a line of smart telescopes, which is where you really made your name. So there's been, for a number of days now, a comet visible. Tell us about it and what you're seeing from your users.
Yeah, so this comet is very interesting. It's called 2023 A3 Chuchichen Atlas. So the name comes from the fact that it was discovered by an observatory in China called Chuchichen, an observatory in Chile called Atlas. And it was discovered in January 2023. Um, Quickly after the discovery, the orbit that were calculated by astronomer revealed that it will come very close to the sun and to our planet. And comets are basically a mixture of ice and rocks. And when they come close to the sun, they warm up. So they have an activity. And the activity can be seen for us human as the formation of coma surrounding it and the tail, and it become extremely bright. So we knew that this comet could be bright. Last year, we observed it shortly after the discovery. And when I say we, I'm talking about the citizen astronomers of the Unistellar network. Using their telescope, they can take observation, scientific observation for us. So we analyze the data and we confirm the orbit. We confirm that it was getting brighter and brighter. We get a better idea of the size. And in April, we also saw some changes in the type of activity compared to a normal comet. So we make an announcement claiming that this comet could be the planet of the decade, and it could be as bright as Sirius, -2, even brighter in magnitude. Well, we were right, because I don't know if you watch it, but 3 nights ago, it was visible close to the sun and with a naked eye. And it's one of the brightest comets we have seen over the past decade.
And for how much longer will it remain visible? What's the estimate here?
So for with naked eyes, it's gonna faint very quickly. Yesterday, because of the full moon, it was not easy to see it in San Francisco. I tried with my neighbors. If you find a dark area, you will see it for the next week or two with naked eye. Okay. If you have a binocular, it's gonna be possible to see it for like 15 days without problem. If you have a telescope, like our or others, you will be able to see it for a month and a half, even more. And in fact, the activity is going to be easier to see with telescope in the next months, the next 3 or 4 weeks, because it's becoming higher and higher because it's going away from the sun, it's moving away from the sun. So it's going to be high in the sky when it's night. Right now, it's very close to the sun. So you basically have it into the halo of the twilight, the sunset. So it's not very easy to see it. But in the future, it's going to be much easier to see it with a telescope because it's going to be high in the horizon and observable for several hours in full darkness.
Right now, I'm in New Jersey. It's been low on the horizon and in the west, right?
Yes, in the west, just above the sun when it's set. And if you don't see it at the beginning, don't panic. Just wait a bit. You can play with your phone, take pictures, and you will see that if you zoom with your phone, you will see. In fact, that's what we did yesterday. And then after a while, when your eyes get accustomed to the darkness, you will see it better, of course.
Interesting. Well, tell us about the unistellar telescopes and how they operate, how they're really different from a lot of other telescopes out there.
So they are what we call digital telescopes. They are equipped with a camera. Okay, so when you look with a telescope, classical telescope, there is no device between you and your eyes. Your eyes is basically the device. Human eyes are great, but there is one thing they're not made for. Made for is to see in the darkness. We don't see color in the darkness. We have a very poor sensitivity in the darkness. We're generally good to see motion, but that's all. That's probably because of the way we evolved. Um, Telescopes equipped with cameras are better because they can take long exposure. A human eyes take 25 milliseconds exposure, basically. A telescope with a camera can take hours of observations. So what we do with this telescope is to basically take very short observations and stack them, remove the noise and so on, and stack them to put them together. So slowly, when you look into the eyepiece of the telescope or on your phone, you basically see an electronic image which is getting better as the telescope is collecting more and more photons. It's like if you could open your eye and look at the sky for like 10 minutes and let all the photons of the dark objects come into your eyes, and slowly your brain will be able to see those objects. That's not possible because humans can do that. So we have a telescope to do this, and that's how a telescope does. That's one thing. The second thing is that the telescope is smart. It's connected to a phone, to the phone, so it knows where it's located, it knows the time. So you can basically, it can align itself, meaning that it can find where it's located, it can find where it's pointing, and it gives you a list of targets you can observe. So if you don't know anything about astronomy, the app will guide you and tell you, hey, you can observe this galaxy tonight, or you can observe this nebulae, or you can observe this comet. So that's the idea.
It knows what is visible in the area where you're located.
Exactly.
So, what are you hearing from users? I mean, I've been thrilled with being able to see things that I've never seen before, and the astrophotography capabilities are wonderful.
Yeah. Our user like the telescope. And one of the things that I like is the simplicity. I mean, you have one in the back here. You can see that they're relatively simple. You don't have to plug anything. You just charge them, and then you take them and you go anywhere you want. You can carry them in a backpack. The small one, the Odyssey, is only 5 kilograms, so it's easy to carry around. You line itself, focus itself. In 2 minutes, you're ready. So observing is not a big deal. And that's important because the best telescope is not the bigger telescope, the fainter, the most powerful telescope. The best telescope is a telescope that you use. So what we created is a telescope that people have nearby them. And when they see it's clear, they just take it out and they observe and they have fun with it. They call their friends, the neighbors. They share the beauty of the dark sky with their friends, their family, and that's really what mattered to us, in fact. And I think we succeeded in creating this object, which is part of the daily life of people in general.
Tell us about the involvement with citizen science and how your users can play a part there.
Yeah, so that's the second step. When the users observe the telescope, they have fun, they see galaxies, nebulae, comets, etc. There is more than 7,000 objects you can observe with a telescope in the database. You can observe any part of the sky as well. So, but the next step is to allow people to also contribute significantly to science, to the knowledge of humanity and in astronomy specifically. So we have created basically a device that can receive alerts through the phone or through Slack when there is something happening in the sky. So we have a partner, the SETI Institute, the Search for Extraterrestrial Intelligence Institute in Mountain View, California. And these partners basically develop scientific observations for Unistellar. So we can send alerts if there is an asteroid passing by Earth that need to be monitored, if there is a new comet, if there is an exoplanet that need to be confirmed, detected by the NASA test mission, for instance. If there is a nova, a new supernova or something happening in the sky, you get an alert, you take your telescope out, we take the observation, you send it to the SETI server, we process the data, SETI process the data, analyze them, and you get back a day after a report telling what you did and how you can contribute, you contributed to science. And in some cases, we publish those results, and the citizen astronomers who are part of it become a co-author. So we have published, for instance, the detection of the DART mission a NASA mission that impacted an asteroid, and the people, all the people who observed this mission and this asteroid are co-author of this paper that was published in Nature last year.
And for telescope owners, I mean, we're expecting an interesting month or two ahead, perhaps. Are we still waiting for the nova explosion or something
Yeah.
along those lines?
Yes, so I just yesterday someone asked me, we have 1,283 observations of this novae, potential novae. So every night we have, I will say, between 5 and 10 people who observe this star in the hope of being the first one that detect the explosion, the novae that has been predicted that should happen between April and September. And today it's October 17. So the novae is late by 17 days, which is okay because astronomy plus or minus 2 months, it's fine. We can deal with that. So
And
we're
it's a
gonna
few
continue.
light years away, right? So,
Yeah. We're gonna continue to observe it, and hopefully our network will be the first one to detect it. That's kind of the game at the moment. We have implemented an entire system where you can get an alert on your phone if it's happening. I will be waking up in the middle of the night if it's waking up, and one of our citizen astronomer detect it.
exciting. So where can people go for more information from?
So to know more about our telescope, you go to unistellar.com. And to know more about our citizen science program, you go to science.unistellar.com. And you will see all the scientific observation we prepare, some of the results, and it's relatively easy to use. If you have our telescope already, and you have not yet joined the citizen science program, just click on the menu Science, register your telescope, and you will basically be invited to join our Slack. That's the way we communicate with our citizen scientists at the moment. And and you will learn by doing it. In fact, that's the best way to to learn how to do science is by doing science and being part of the scientific community.
Exciting. Again, unistellar.com. Franck Marchis, thank you so much for spending time with us.
Take care.